Okay, welcome back. So this is a polynomial identity. Okay, we're supposed to do something. So I'm gonna, I don't know, what? So probably by the time I've managed to get this stupid whiteboard to do what I want, the audience has already figured out like n equals 3 at least, right? So for n equals 3, this is, I think, just this abc plus 1 over abc plus like, let me just write it here this way. This is a true identity, right? Yeah. So that's true, which is fine. And then is a drink energy drink? I don't know, but it's good. I don't think it's an energy drink. I think it's like Calpico water or something. Okay, so what is the thing for ABCD? It's like, for 4 variables, I'm assuming the polynomial is unique, right? Because I don't see how it could not be unique. So there is some identity, and this, what is this? It's like ABCD plus 1 over ABCD, and then plus, what are the what? Oh, jeez. I feel like they did cyclic. What do I do for the other things? So I have like AB, yeah, sure. Something like this, right? I don't. Symmetric is the wrong word. It's like the pairwise products of. I'm just gonna write 6. I don't know what else to write. No, wait, sorry, that's way too big. Hang on. 6, 4. No. Let's back up. No, wait. There's some. There's some constants too. Hang on. Okay, wait, hang on. Let me actually. No, sorry, I think I want 6. Right? I want the cyclic sum. So if I do the cyclic sum. Okay, let me actually verify I get the right things. So on the right, so there's big term, there's small term. There's a bunch of constants, like this left-hand side is the ABCD plus 1 over ABCD, and then how many constants are there? There's a constant for A times 1 over A times C times 1 over C. 2. So there's 2 of those, I think. And then there's the degree 1 terms are AB over D. There's ABC over D. Oh, this is very no, sorry, there's no ABC over. Hang on. AB plus BC plus CD plus DA. So how many things do I want total? I want like 16. So if this is there, then there should be the reciprocals, and then DAB. It's fine. And then okay, whatever. For the degree here, when I do this cyclic sum, okay, I do get the AB. I guess the point is I want to take like. If I forget about the constants, because I don't think I'm super worried about those. Shut up, Kaiser Permanente. That should be fine. So this guy is AB. Crap. I do have an AB over C. Is that right? That's not. No, hang on. Ah, crap. Wait, hang on. Where did I get this AB over D from? Sorry, I'm stupid. This term isn't there. How did I write this down? It's AB. No, I'm just stupid. This term isn't there. ABC over A. No, it's just PC. It's like B over D. Sorry, that's what I want. And there is a. I do have an A over C. Okay, so up to constants, like if I. Yeah, so there's some constant that makes this should make this true. Like, I think it's like 6, I think. Or not 6, alright, 4, 16, minus 2. I think once I stick in a minus 2, that's the identity I want. Okay, so something's happening. Okay, so humor me for a moment. I think this will probably not do anything, but I'm curious to see. If I write this down, so this is the n equals 3, but I write just that. So I guess it's really the. Because I feel like the problem with is that it's kind of cyclic, and I kind of want to just cut it open and see what happens. What does this equal? This is like ABC. Thank you, Pengu, for the follow. Plus 1 over BCD. And then what are the cross terms? Looks like this, right? So this guy here, this is one thing. These things are actually, like the main thing is like this thing has a weight on it, and otherwise it's almost the thing I want, right? And this thing is like whatever. Maybe construct the polynomial? Hmm. If I multiply this by like another term, right? If I take this and then I stick on a d+1 over e, like what do I think happens to it? So there's only really one term that I am not happy with, which is this, like this in the n equals 3 case, which looks like, or the, I don't know what you want to call this, the like, three to 4 case, we'll just call that. Right, there's only one thing that I actually don't like, which is the fact that there's like this a over d. Like this a over d is the only thing that makes it not a polynomial in the 3 things. Right. This guy, this guy, this guy. And otherwise, it's almost a polynomial. So if I multiply on the green d+1 over e, what happens now? So this stuff is all okay. So what happens is I get abc+1 over bcd times my new d+1 over e, and then some stuff I don't care about, and then the thing that's new is this a over d b+1 over c times d+1 over e. So this is the term that's not a polynomial that that's going to kind of change, and then here's stuff. So when I clear that out, so I do get, so the terms that are left over, abcd +1 over bcde, these are okay. And then I have some new stuff, which is, oh Jesus Christ, 1 over bc plus abc over e. So these are bad. So new bad guys appear, and then alright, I guess it's this, right? Plus a over d b+1 over c. I mean, so what's supposed to happen is that when e equals a, I should get the n equals 4 thing I had before. Do I? Did I screw up the work? When e equals a, bc +1 over bc. Something's weird there. That feels like it was supposed to resolve more nicely. Huh. I mean, okay. Here, I mean, this guy here is. Let me keep pushing. This is. I still don't think this will work, but it's working a little better than I thought it would. So this is the thing. This is the red stuff is still there. That's the stuff I want to keep. And then I guess what's happening is like some of these things combine, right? So there's the a over e part that's always kind of, this is the part that we're not happy with, right? And then there's something inside. That something inside is... Hang on. I feel like the degrees aren't the right parity. Oh yeah, no. This is a plus 1 over d, b plus 1 over c. Oh, that's interesting. So 1 over d showed up. Is that? How did that happen? In some sense, I really wanted this one to be... I wanted this one to be like an E or something, so that it's still polynomial in the 4 things I had, but it's not. Really? It's 1 over D? Meanwhile, yeah, and the part that isn't screwed is, yeah, it's like a plus 1 over b, b plus 1 over c minus 1. I feel like I'm off by 1 somewhere. Somewhere along the lines, something got messed up with the parity. Yeah, something's a little... Oh, I'm missing an a over c term. Nah, crap. But what? Oh, okay. Here's what I'm missing. I'm missing a BC here. There's a plus BC. Is this remotely checking out? Hang on. All right, let me move things a little. So I think what I'm getting is that okay. Let me write down the claim completely. And a lot of this came out of our induction. The point is that this is equal to abcd plus 1 over bcde, and then plus some things that are almost polynomial, and then like one thing that isn't. So it's, we have this a over e term, like this stubborn a over e term is where the difficulty of the problem is coming from, I think. And inside here I have something I'm gonna have to refactor this a bit. That's it, because it's not quite what I want. And then stuff outside happened to factor. I got a plus 1 over b, b plus 1 over c minus 1. So this part's okay. And then some other stuff that is okay and I don't honestly really care about. But turns out to be equal to the new term d plus 1 over e times old stuff, which happened to be c plus 1 over d plus 1 over. So this is where I am now. And what happens is when a equals e, this part's okay, this part's okay, this part... So I need to still massage the thing inside, right? Somehow. DC, DA, AB. So I think what happens is by some black magic miracle, this thing will be equal to something else. This thing will be equal to... okay, what it's supposed to be equal to is, let's see, I have AD, AB, D to A to B, C to D, so it should be B to C. plus -1. No, that's not right. This is like 5 against 3. Something's wrong. I have a calculation error somewhere. This doesn't check out. Yeah, somewhere along the lines, something died. What did I do? Oh no. Oh, okay, I see the mistake. Yeah, this A shouldn't be here. The A is fake news. So it should just be that. Now it checks out, right? Cool. So if I was trying to claim we define px, then p of I. What is p of I? You want to use complex num? Never mind, it's spanning. Okay. So okay. Fine. I almost want to just multiply by e+1 over f and pray. You think we should try to pushing this once more, or is it going to crash and burn if I... Because we don't care about... So, I have this green stuff, but the green stuff is all fine. Like, I don't... It doesn't really matter. I think the general shape is that, if I look at... Like, if I want to try to push this method, all the way through. The general shape of the method is that there's going to be a claim, and the claim is that a1, if I go all the way up to an plus 1 over an plus 1, there's going to be, so there's the product from 1 to n of ai, plus the product from 2 through n plus 1 of ai, 1 over ai. So, you know, the main, whatever it's called. I don't know if there's a name for it. And then there's going to be one part that is contaminated, like this. That's this. That's this weird part here. That's kind of the only thing that prevents it from being a polynomial. So it's like a1, an plus 1 times some blob. And then everything else is a polynomial in things that we don't care about. Could it be combo? Honestly, I would not be surprised if it's combo. I've had this, I don't know. But basically the thing is, if I can describe what the yellow blob is, and then show that when I tack on the next factor, it's okay, then we're home free. So let me give this a name. We're gonna call it capital P. Let's do n. All right. So the experimental data we have so far is that the first time it was literally just the product of the two. No, it was b plus 1 over c. All right. So for n equals 3, it's just b plus 1 over c. And then for n equals 4, it was b plus 1 over c times c plus 1 over d minus 1. And now it's like, what if I keep pushing? What if I keep pushing? So this would amount to multiplying the thing above by e plus 1 over f. Alright, I'm gonna try it just to see what happens. It might be too messy for me to figure out what's going on, but I would feel stupid if I didn't try it. So we're gonna try it. So when I multiply by e plus 1 over f, meaning we're now going on to n equals 5. Right, so what's going on? So here's the contaminated bit. C plus 1 over d minus 1. Now we're multiplying by e plus 1 over f. And then also we get two new terms, right? So the two new terms that spawn are what? One abcd over f plus make sure I get that right. 1 over bcd. Am I scared yet? I'm not scared yet. Let's just keep going. Okay, so the part that has a factor of f, which will be the new p, is bcd plus. What I'm scared of is that I'm basically trying to postpone crashing and burning. It's possible what happens is that by doing this kind of thing, there's a ton of complexity, but I can't see it because I only have like 3-ish variables inside the bracket so far. That is the thing that I think could happen. But on the other hand, I really don't think this is that bad. Ah, shit. All right, so two things need to happen. First, I need to show that this new thing here is a polynomial in the culprits. This looks like it might just be. Is this just the previous case? This looks like it's. Hang on, what's the total? 3, 4. I mean, we can see what it is, but I feel like it's. Yeah, there might be a combo interpretation, but I don't see it yet. I screwed something up again. There's no E here. The point of the, no. Wait, what? There's no A here. I keep putting this A where I don't need it. Let's see. Okay, so the new part in here is what? This looks like it just wants to be d+1 over E. Well, okay, the product b+1 over C, C+1 over D, d+1 over E, and then minus like something. It's okay, I see the BCD. I don't really care about the -1. Minus b+1 over C. The -1 just stays over. Is that true? Did I? So the current strategy fails. Oh, is it actually just not a polynomial in the things I want? N equals 6 is the first non-trivial case. Oh, that's sad. Are you telling me? So I'm I'm getting that I want a minus d here, which I agree would mean that I'm this screwed, if that's actually correct. If this expansion I just wrote down is fine, then this strategy is doomed. Because it's not a polynomial anymore. I really don't want this to be correct, but I think this might be... if the blue thing I wrote down is correct, then this can't work. Really? Oh, alright. Okay. Okay. Yeah, alright, we're dead. Okay. It was worth a shot. This one term. So the other part is not a polynomial either then, right? Is what has to be true. Because I thought it might just be like... Yeah. I think this is anti-problem? Why is it an anti-problem? Oh, I don't even know the solution yet. Okay. Back up, back up, back up. What is a polynomial? What is this poly enumeration you speak of, and what does it do? You want to use Burnside? I mean... Okay, so this generalizes... Oh, I have no idea. Okay. Well, back to the drawing board. Do we have a... Okay, so apparently we managed to compute what the polynomial is for 6. the original one, not the sliced version that I was trying to use. Manually solve for A1. Okay, so you want to say let x1, x2, etc., and then solve for A1. Is A1 to A2 a Mobius transformation? What does that mean? Yeah, the 142536 is kind of scary. I agree. I don't want to listen to lo-fi. If I... We thought there was cosine... Like, okay. Like, if all the areas are equal, we know that this will be the Chebyshev polynomial, right? Does that tell us anything at all? Like, I almost want to let each AI be like a complex number on the unit circle and then try to do some... Then one of all these things will be like sums of thingies, whatchamacallits. Suppose you have n dots around a circle. All right, very cool. And remove adjacent pairs of them. Okay. Every time you do that, multiply by -1. What? Wait, that's beautiful. Disregard the disregard. No, the constant should come from. Oh no. Well, I think the claims the coefficients have all been plus minus 1 so far. Maybe. Maybe that way. Actually, that might not be true. Like, it is true we've only seen plus minus 1 coefficients so far. Besides the constant term. The constant term seems to, but I'm a little right, but okay, when you have a larger thing, there might be multiple ways to remove adjacent pairs to get like oh, I don't know. Only appear once. IDK. Well, I think including the F there is fine. I don't think you need to change that to IDK star. Yeah, no, it should be -1 to the, I don't know, like number of all right. Well, I think the claim is that it's a sum over... Like, it's not like you sum over... Like, I think you're trying to sum over... I think it's 6, not 5 here. Okay, I'm gonna try to write down something, and whatever I write down will be wrong, but maybe we can fix it. The claim is that when you do the sum over... Oh, this is so stupid. I don't even know what to call it, like deletions of like the product. We're gonna let x1 be like a1 plus a whatever, of like product of leftover xi times -1 to like something about the deletion. I have no reason to. Yeah. Why on earth would this do anything? Yeah, it's like that mob problem I have in SimPoly where is trace a1 through an a polynomial in trace 2? Desperation increases. Why are there minus signs? My thing just trivially works by play. I think I see the light. Please enlighten us. What is going on? Your claim is that for a fixed term... Oh, I see what you... Okay. Your claim is that I take a thing with the correct number of parity, like take some leftover term, I claim that it's there if and only if it's the top or the bottom. And the reason is that... I can't believe this is legal. What the hell is going on? Like say you actually have a circle, right? And you're looking at like some term. Let's just draw a lot of dots on here. No wait, but okay, like. I don't know what's going on, but I will say the argument feels... This feels like the kind of thing I was... I don't know. Because I guess the point is the following, right? Like, suppose I have some term that I'm interested in. Let's just make one up. Like, A1, A5. Okay, I did 13, so I need an odd number of things, right? 1, 5, 6, right? Let's do this. Right. So, dude, I don't know what's going on. Oh god. GeoGebra. You're using GeoGebra for this? That just seems like... Okay, anyways. Oh wait, sorry. When I'm talking about terms, there should be tops and bottoms, right? So like, okay, sorry. Let me do something like a1, a5 over like a8. Okay. So that means I'm looking at things which have this guy survives, and 8 is like this thing. No, that's not also... Because the problem is you have all these... Okay, actually I'm not... Oh god, this summation is so bad. But certainly A1, if I want to have a term like A1, A5 over A8, I need these 3 dots to be left over. And then there's a bunch more things that happen where I don't know what the hell is going on. What the fuck? Spam. 1, 4. Alright. So which things contain x1, x5, x7 in them? And then what other... Wait, this seems like something happens. Yeah, does the same thing. Okay, you guys are way ahead of me. I don't know what's going on anymore. But I guess your point is I want to fix a term. What is going on with the Mobius transform? I don't understand what's going on with the Mobius thing. It's like, are you solving? Are you actually solving the thing? For... Alright. Take a quadratic irrational. Alright. Take all the parts you get while generating the irrational. I leave to eat dinner and now there's a circle. Yeah, I think there's some black magic happening. I'm not really sure exactly what anymore. But I think there's multiple, like... There's a claim that you can write the desired polynomial as a certain combinatorial thing where you delete adjacent pairs. And then there's some other claim about continued fractions. And then there's a third claim that these two things are actually the same. And I don't understand any of the 3 claims, but it's okay, we roll. Generating the irrational, norm the product generators. Can we make the deletion thing precise? So is it actually -1 to the number of... I'm actually, no, I don't quite believe that. Look at the matrices 0, 1. Oh my god. There's more black magic. Alright, what's going on here? You wanna build this matrix? I don't think it's an anti-problem. I think it's just hard. I agree that this feels like someone should have told me that it was true. I had the same feeling. The numerator of the fraction is... What is going on? Numerator of the fraction... Sum delete -1 to the delete. The thing you wrote. But so like, is it with multiplicity? Like when I have 1 4, right? Like there's. I think deletions is the wrong word, right? It's actually the sum over like dot configurations. Like when I initially thought it was like methods of deletion, but I actually just think it's literally like. Well, actually, at least looking at the example for n equals 8, I think it's literally sum over dot configurations for which any two consecutive dots have an even number of things in them, and then like -1 to the size or something like that. And then there's a constant at the end. I don't know what's going on with the constant. But actually, we don't care about the constant, right? The point is you only care about leftover things, and then something's going on. Okay, so you have a thing with... What the heck? Are you serious? So, okay, the claim is that TI has... What the fuck is going on? There's like 3 different solutions happening now. TI is... So you find that a1 comma... It has a single eigenvector of 1, 0. So one of the eigenvalues is 1. The determinant is... Oh, the determinant of the composition is 1. So the trace is... How does the trace thing work? Either choose to... No, I think that's combinatorial thing. 1 over sum of... So the other is... Wait, but is like the trace... If I stack a bunch of these operators, the trace is not the... What's the relation between the trace of the entire product and the trace of the individual things? Right, so I agree that like... No. Like the entire product has O. Okay. So I don't need trace then, right? Like what I want to say is the determinant of the whole thing is 1. No, don't I not need something about the trace? Removing pairs. Yeah, good job. Good call. See, I believed early on, even though I had no idea what was going on. Oh my gosh. The trace is the sum of the eigenvalues. I agree. But the... Oh, I see. So the trace is a polynomial in the things, and the entries are, and the trace... Hang on, let me actually multiply this thing. When I multiply this by 1, 0, what do I get? Hang on. Now I'm... No, that's the wrong thing. Are you sure you gave me the right eigen? So I read the determinant is 1. You told me 1 comma 0 is... Did I copy the matrix wrong? 1 comma 0 doesn't look like it's an eigen thingy. You know, something's wrong with the eigenvector, I think, right? Multiply it by a+1. That shouldn't matter, right? Like, eigenvectors are only can be eigenvectors can be scaled, so I think something's wrong with. Right, like what's going to happen is this will just be minus ai+1 0. That's not an. Unless you're saying I keep applying it. Oh, are you saying it's not an eigenvector of the individual matrix and then I keep ping-ponging it? But then I feel like that should depend mod 2. Seriously? Okay, wait, let me actually try this. So you're telling me that if I start with... But like, if I start with 1 comma 0, it's the same thing should happen, right? Like, I don't... Oh, okay, let's do this. Yeah, so you're telling me if I take something with a 0 here and like... It shouldn't matter what I put. If you want me to put B, I'll put B. But then... So the B moves down here. Yeah, no, this gives me something like... Minus B? B? Sorry, 0 comma B, and then now when I do this again, I get B, and then what the hell? B squared plus. Am I writing the right thing down? It's not B comma 0. Wait, what? Oh, Oh, you have 1. This is 1. That's why it's not working out. Okay, never mind. I was like, the 0 thing just doesn't work. Okay, cool. That makes a lot more sense. Yeah, now it's 1. Wait. No, but now this is like A minus... Wait, what? You want A comma 1. Okay, let's try that again. A comma 1. And then... So you get 1 over B. Which is a multiple of B comma 1. Okay, and I see. Then the induction goes through. Okay, yeah, I agree. That's fine now. That works. I think some black magic happened here. I'm not really sure what's going on anymore. I agree this is a complete solution. Yeah, okay. You kept writing A1 comma 0 and I kept being like, what is that? Okay, it's A comma 1. Yeah, I agree with A comma 1, it works. Yeah, that's why I was just like, it's not working. It's a yeah. You need a 1 in the bottom, not a 0. Then it's fine. All right. Cool. I want to understand what's going on with the circle as well. Is the claim actually just that the polynomial is given exactly by... Okay, it's the thing I actually think it is, which is, so it's the sum across subsets of 1 through n such that consecutive elements have even gaps. Elements in S have even gaps. And then just literally the product of xi for I and s, and then a sign for n minus s over 2? I need to scroll so it's in view. So the claim is that it's actually exactly this polynomial, right? It's not even... The trace solution might get you this. Yeah, maybe. I just want to first make sure I have the right thing written down, because But I think based on what people have been saying, it looks like it's this. And then like plus minus, plus some constant I don't really care about. What do you do with 16.7 channel points? You can... We can have a 3-minute ad break. That is one of your options. Oops. Didn't need to do that. Well, this is certainly a problem. Wow. It's actually exactly this. If I believe this, then the way I check it is... So I guess the constant term's a little different, but as long as I have like any particular term, like a1, a5 over a8, then I'm looking for things that have 157, and then there's some contribution from whatever other things that could be in there. And the claim is that they just disappear by pi. I might believe that. Well, okay. So I would need to actually say, in order for the other things... Oh, it actually is exactly that. In particular, I think this thing has coefficient 0, right? Okay, no, we know it's supposed to... It's, well, what did I want to say? 1, 5... Wait, now I'm confusing myself. I don't think there's any contribution at all. It's not even like... There's actually no contribution at all. There's no set S for which I get this a1, a5 over a8 term. So I don't even need to sum across S. Right. Yeah. Wait, actually, I think it's actually exactly this. Yeah. Wait, that's absurd. What am I doing? Now that I've written this down, I'm just like, wait, this obviously works. And I also just picked a bad example. I should pick like 9 or something, right? Then at least there will be a non-zero contribution. Like this. And then you actually have something to... No, shit, this still... freaking heck. Sorry, let me... what's a good way to do this? Okay. Hang on, let me pick a better example. 6, 9, And then we can do like a1, a6 over a10 or something. Right, and then the point is that now there's a contribution. The contribution comes from those things that contain this thing, and then maybe there's some more stuff in between, like, I don't know. Can you split even gaps into... Like, you could have this, so those cancel, or whatever. But then it should just be pi. Yeah, like, it actually is... It's a little tautological, actually. Like, this has been rigged so that it is what it is. So the things that will contribute correspond to it. In order to get this, you need to have these 3 red dots. So S should contain 1, 6, and 9. And then any more red dots you have should correspond to things that pair up. Like, you can have a... I don't know, like here or something. And this would correspond to like an A4 canceling a 1 over A4. So it's like this big sum across things. You have some space thing, and then, yeah, what dotted said. Yeah, and then also it's a little different for the constant term because then there's nothing to anchor you on, so I guess, you know, something happens. But constants are polynomials, so it's okay. Right, so then it's like how many ways are there to do this times, and there's like a sign flip for every thing you add, so it's literally a pi sum. Which, huh. So I feel like the deletion thing was... Sorry, I got confused. We should have just said this. Like, it doesn't even matter that... Like, when you're describing what the... whatchamacallit. When you're describing what the polynomial is, you don't even have to think about adjacent deletions. You only care that the gaps in between them are even. And so actually, if we had done examples up until... We went up to, like, 5. But I think if you had actually written down all the examples up to like 8 or 9, this formula would be pretty easy to guess because the coefficients are literally plus minus 1 and then yeah, so the deletion thing is actually the proof, not how you write the formula. Wow, okay. What a problem. GG. Where is this from? That's now my question. Because I agree with the sentiment. I feel like someone should have told us about this a long time ago. Because we've all seen the n=3 version. Or some of us seen. Those of you who took SimPoly have seen it because it kind of shows up there. But you solved it faster than math.sc. Yeah. Asked yesterday. Oh, this is original. I see. We just... Oh yeah, that's the major. Special thanks to Darius Green. Okay, well, we're definitely putting this... I'm trying to decide whether I want to put this in, like... real poly? Is this real? This doesn't feel like real poly, though. This feels like sim poly, except it's way too hard for sim poly, because sim poly is a B-level unit. Okay, let's write this up. This is good. Let's how do I? The screen? No, that's the stream. No. All right, there we go. Okay, well, if the first time this was listed was on math.sc, that's probably a good canonical URL. (509 57573). Right, we did upgrade that recently. Oh no. One moment, please. Let me... Yeah, I think I agree with that assessment that the matrix approach is shorter and the combo approach actually tells you what's going on. Okay, GP is strong now. Amazing. That's actually a little terrifying. Huh. Because the last time I tried to plug anything into the public models, it did not go well. All right. Okay. Paragraph. Actually, I think this I'm more gonna. What was the matrix we picked? 0, 1, minus 1, a1 plus 1 over a2. I wanna note that we have that ti equals 1. Note also that t1s times, so the vector we multiplied on was what? We picked a1 comma 1, right? Equals 1 comma 1 over a2 equals 1 over a2. 1. Okay, so in particular, if we compose the matrix oops, this should be sequence, we find that tn minus 1, t1 matrix C, a1, 1 is equal to however, so the determinant of tn minus 1, ergo determinant to get a single matrix T, we find that so the eigenvalues of T are exactly a1, an, and 1 over a1. This is ridiculous. In particular, now we look at the trace. It's not, we don't care about the trace of the individual bits. Trace is given by that, and so however the trace of T however every entry of T is a polynomial in the given by matrix multiplication. Okay, and then for the combo thing, what we're going to do is we're going to say let x1 equals a1. So on. We are going to give... what is the other eigenvector? That's a good question. I don't know if I believe that it's simple. Someone want to like crank out n equals 3 and see if it's anything good? Is det t not 1? Yeah, determinant of t is 1. No, the question is what's the other eigenvector, not the other eigenvalue. We know the eigenvalues, but the question is like, is the eigenvector any good? My guess is no. some constant c. C plus sum. -1 to the n minus s over 2. Where the sum is taken over all subsets, all non-empty subsets, S subset 1n, with the property that when the elements of S are marked in a circle, the gaps between consecutive elements in S are even. For example, for n equals, what was the one where we had n equals 8, right? Or something? Let's just do 6. I think 6 is clear enough what's going on. Or 7? 8? Okay, 8 should be fine too. Oh, this is so annoying. And then plus cyclic sum of x1, x2, x3, x4, x5, x... Can you please show the problem again? That thing. I mean, it's on the source code on the left too. Okay, I think 8 is too annoying. Can we just do... Actually, 8 might be okay. Let's do... Let me write down 7, I think. 7 is actually a little easier to write. Oh shit, this is b minus. 1, 2, 3 plus sum x1, x2, x5 minus cyclic sum x1. The proof essentially follows the principle inclusion-exclusion. I honestly don't want to write out the rest of it because it's super annoying. Easier to see from an example. Consider for n equals 7 the sum above and the and the term x1, x2, a1, a2, let's say over a6. This term can only arise from product of xi's that includes x1, x2, and x6. And in fact, from an S with 1, 2, 6 superset S. Sorry, subset. And it comes from the following four terms exactly. So x1, x2, x3. Sorry, I messed up. This should be 5. 5. Also, that's not how you type. A7? 1 over A7? Or is it A? Wait, shit, which one is it? So 5 is a 1 of 6, 7, yeah, 7, no. Hang on. Oh, it's flipped the other way around, that's why. Also, let's say a subset S is even spaced if when I think I should align this, right? Okay, and then if we fill in the gap for here, instead we drop. So I'm missing some left and rights, right? This is the part where I was like, yeah, maybe I should switch to types. Then you never have to type left and right again. Okay, this is if I clear out the 3, 4. This one's a plus, this is a minus, this is a minus. This is if I keep 3, 4, 5. And then finally the 1, 2, 5 itself when I don't have any of these terms. Okay, I think if I write it this way, I'll be able to remember what's going on when I see the solution again. Yeah, types does not require left and right. Types also doesn't require a backslash. It's really nice. Yeah. And indeed, the total contribution is 0. These are the only sources of a1 to the plus, a2, and meanwhile, a term like a1, a2 in general, each term that could appear corresponds to some set, some base set, since 1, 2, or a1, a2, a4 maybe is a better example, since 1, 2, 4 is not even spaced. This is despite there being for an non-constant term to be possible, the set of indices needed for it must itself be even spaced. Yes, third row should have a minus sign. I agree. Good catch. All right, we did it. Good job, team. Thank you for carrying. I did not contribute very much. I had this. I mean, I think trying the induction was the right thing to do, but ended up not working, which is fine. And then Twitch chat just solves the rest of the problem while I'm goofing off with that. All right, very nice. For those of you watching on YouTube, thanks for tuning in. This was a great problem. Hope you liked it. See you next time.